Good afternoon, everybody. This is the 2023 Dairy Team webinar series. Today's program is evaluating forage storage options for your farm. Our presenter today is Brian Dougherty. He's a field agricultural engineer for Iowa State University Extension. His dairy-related extension work focuses on facilities, ventilation, manure management, composting, and the effects of cropping systems on soil health and water quality. Today, he will discuss factors to consider when evaluating forage storage alternatives for your farm. He will cover general facilities, siting and design, and discuss tools and tips for selecting the best fit for your operation. Brian, we're delighted to have you here today. As I always say, the podium is yours.
All right, thanks, Fred. I appreciate the opportunity to be here. So yeah, just going to talk about evaluating different feed storage options for your farm. So we'll kick it off here, just talking about some different factors to consider for different types of storage, and I'll get into economics a little bit. I don't have a lot of information on that, but I'll touch on that briefly. But what I'm probably going to spend the bulk of the time covering is facility siting. So one of the issues that I see pretty regularly with facilities isn't necessarily the design of the facility itself. There's issues around where it's located. And then we'll talk about some design tips as we go through as well. So factors to consider. Well, obviously, if we're talking about forage here to start with, what type of forage you're dealing with, the size of your facilities, how many animals do you have, what are you comfortable with as far as capital investment? Obviously, if you're pouring concrete, doing bunkers, that sort of thing, that's going to be a little bit more upfront cost versus bags or piles. You have to think about labor to fill and empty these facilities, access, I'll talk about as we go here, locating those facilities so that you can get to them and you're not too close to other buildings where it's causing a traffic issue. Convenience is another one. Do you have feed storage facilities scattered all over the farm, or are they all in one place where you can have a central mixing facility? And then there's issues with drainage and water runoff that I'll talk through as we go through the presentation here. And another thing I encourage people to think about is just flexibility. So let's say you're going to build a new shed. You have an intended use for it right now, but think about the future. Can you use that shed or that facility for something else, 10 years or 20 years down the road if you sell the cows or you change how your farm is operating? So we'll start with silage. So storage goals for silage. You need adequate size for your storage period. And then the main thing here is we just want to minimize those storage and feed out losses. And that will be affected by what type of storage you're using and how you're managing that. And ideally, you've got a situation where you can transition gradually between different feeds, first crop versus second crop hay, for example, things like that. Do you have a system in place where you can make that transition gradually, or is it going to be sudden? So thinking about bags versus piles versus bunkers, you have to look at the economics. And the best way to do that is to just evaluate those different options on a cost per ton basis. I'm not going to get into the details on that, but I'll show some links to some economic tools later that you can use to do that. We have to factor in shrinkage loss. So that's a big part of that economic calculation. And that's going to vary a lot depending on how this is being stored and managed. Again, logistics, how much space do you have? Can you achieve adequate packing density? If you don't have big tractors and you can't fill a bunker very quickly, maybe you're better off just going with a bag or something like that to get that packing density. And can you feed out fast enough to prevent spoilage? So just comparing the different options here, they all have advantages and disadvantages. There's no perfect way to store feed, and you may have, more than one or even all of these on the same farm, depending on your situation. But your bunker generally is going to be, very high capacity, small footprint. You can get feed in and out very quickly. But on the downside, it is a high capital investment. Generally not very cost effective if you've got a small herd. Again, there's issues with getting that bunker filled fast enough. You might have to custom hire someone to do that. And then can you feed out of it fast enough to keep ahead of it so it doesn't spoil? There's also safety concerns with, both drive over piles and bunkers. This, sometimes gets overlooked. If you get those really tall silage faces, there's a risk of those collapsing, and there have been people that have been killed from that. So we have to think about safety when we're working around these facilities as well. Moving on to drive over piles, obviously much lower capital investment, very flexible, very adaptable, but they do take up a little bit more space. There's a varying feed out rate because you don't have a consistent sidewall height on those. It's more of a slope design, so a little bit more challenging to feed out of a drive over pile. And then we go to bags. These can be a very flexible option, fairly low capital investment if you can rent a bagger from someone else. If you have to purchase that bagger, then your capital investment is going to be a bit higher, very flexible, easy to inventory. And of the three options, this probably has the lowest dry matter loss. So that's an advantage of bags. But there is that high annual out-of-pocket cost. You're buying plastic every year to, for those bags. It's probably got the largest footprint as far as the area that those bags are going to take up. And you can see the rest of the issues there on the list. So again, there's no perfect way to store forage. You just have to weigh out the pros and cons and see what works best for your operation. But looking at shrinkage loss, so we start with bags on the top. Again, that's probably your best option. If you look at all of these different ways that we have shrinkage loss, filling it during filling, there's seepage, there's gaseous losses, there's losses during feed out. So if you look at bags, somewhere in that 9 to 14% range is kind of what you can expect for, total dry matter loss. And then you move down the list there, bunkers are next. Obviously, if you don't cover your bunker or you don't cover your pile, you're going to have much higher losses in that case. So at least covering those from an economic standpoint is kind of a no-brainer to buy that plastic and get those bunkers or piles covered up. Just looking at cost here. So this is some older data. This is back from 1998. And we do need to probably do some work and get some updated numbers here. But I think the general trends would probably remain the same, even though the costs may be higher now than they were then. But just looking at a comparison here of tower silos versus bunkers versus piles versus bags. So this is looking at what they're calling a small volumes. This is about 380 tons of feed storage, and it's well managed. So in that scenario, the pile actually comes out with the lowest cost here. But as we look at larger volumes of feed, so now we're looking at over 3,000 tons of storage. Now the bag actually comes out ahead here versus the pile. And the difference here, I apologize, the colors are a bit hard to make out, but it's mainly equipment. So if we look at the cost here with the bag, this is assuming that you're going to purchase that bagger. So you've got a higher cost. Whereas we go to, the larger feed storage, you're spreading out the cost of that bagger over a lot more tons of silage. So your cost per ton goes down. Now, this is assuming good management. So what happens under poor management? So this is assuming that bunker, that pile is not covered. So again, bags come out ahead here. Your bunker and pile costs go up because you're losing dry matter loss. So you have to factor that in. Your costs are generally going to be actually lower per ton if you go ahead and cover that bunker or that pile. Moving on to hay storage, same deal. We got to consider shrinkage loss if we're looking at the economics of that. So inside storage obviously is the best option. 1 to 5% is kind of what you can expect there. Outside storage, if you're just putting them on the ground, then it kind of depends on how long they're going to sit out there. So 9 months or less, probably going to be somewhere in the 5 to 20% range dry matter loss, depending on your climate, how often that hay is getting rained on. And then leaving it outside for 12 to 18 months on the ground, you can have a tremendous dry matter loss, though, anywhere from 15 to 50%. So there's lots of things you can do to bring that number down without having to build a hay shed. So you can get those bales off the ground, put them on some crushed rock or some pallets or tires or old utility poles, anything you've got laying around that you can put on the ground and set those bales on top of. That's going to help reduce that shrinkage loss. You can net wrap them, you can tarp them, you can sleeve them. So all options there to bring that shrinkage loss number down without having to build a hay shed to store that hay in. So there's an old saying here, farmers who store hay outside will pay for a barn whether they build it or not. Is that true or false? I think, 30 years ago, that probably would have been pretty true for most people, but with the economics of construction that we have right now, the very high costs for steel and lumber, I'm not sure that's really the case anymore. And so our classic answer and extension is it depends. You really have to put the pencil to it and do your homework on this to see whether or not you can actually make that hay shed pay. So there's some tools here that you can use for that. So I'm giving a shout out here to the University of Wisconsin. They've got a great resource here, their Team Forage page. They've got a whole bunch of different tools there. You can see in the yellow box there, there's the page there. There's a forage inventory and needs calculator that's can help you walk through some of these calculations, some of the considerations for, bags versus bunkers and piles and things like that, as well as hay storage. And I do want to mention grain storage. I know we're talking forage here, but a lot of dairy farms are storing dry grain as well. So question there is, do you actually need it? If you have it, does it need to be expanded? Are you lacking storage space? Are you having issues with grain quality? Because that can be a significant financial cost if you're storing that grain and it's going bad on you. I mean, do you need a grain center? If you have a marketing plan and maybe you're not using all of your dry grain, you're marketing some of that in addition to your dairy facility. So that might be something you want to consider. Or can you just haul it to town? Is there a commercial facility that's got a reasonable enough rate and you don't have to wait in line for a half a day with the semi to unload? That might be a better option than trying to store it on farm. And also on farm, that stored grain needs to be managed. You can't just put it in the bin and forget about it. You need to keep an eye on temperatures. You need to make sure it's staying aerated. You're not having hot spots develop in that grain. So are you comfortable with taking on that management of keeping that stored grain in good condition? There may be opportunities to share grain storage with a neighbor. And then think about the future here again. If you're going to build this, are you still going to need it down the road 10, 20 years? Do you have some kids that are going to take over the operation? Will they be able to use that in the future? These are all things you have to think about before you invest in grain storage. So again, more economics tools here. The ISU Extension Ag Decision Maker website is a fantastic resource. You can go there for all things, economics as far as agriculture goes. There's a hay storage cost comparison tool on there. UW Extension has one for round bale storage costs. There's a grain storage alternatives economic comparison there at that Ag Decision Maker website as well. So I encourage you to check those out. I'm not going to take the time to walk through all those tools today, but they are available. So now I want to shift gears a little bit and talk about facility siting. So thinking about if you're going to build a building, where should you put it? How should you go about laying that facility out? So there's some things that you definitely do want to do if you're going to build a new facility. And number one here for me is just make sure it's accessible with the largest equipment that you think you might need to get in and out of that facility. So we're often talking about semis here. Think about, the labor it's going to take to get feed in and out. Again, account for your location, for your topography. Where's the runoff water going to go? That often gets overlooked when people build facilities and then they realize they have a problem after the fact. And then you always want to plan for the future when you're going to build anything new. Think about future growth. Think about other uses. If you build it and then you stop milking cows, is there something else you can use that facility for where you can still help pay for that over time? And there's definitely things that you don't want to do. And so one that I see fairly often is you just kind of tuck it somewhere, out of the way in a kind of a back corner of the farm because there's nothing else there. Drainage, again, put it in a poorly drained area, a low spot, or too close to surface water, too close to, ditches that maybe don't flow year round, but they do flow sometimes. Digging things into a hillside to make them fit can often, cause more problems than it's worth. Steep driveways are a problem. Make sure your doors and your sidewalls are big enough to get equipment in and out. Make sure it's wide enough if you need to turn equipment around inside the facility. Think about leachate containment. If you're talking about silage here, all of these things are things that often get overlooked, or people try to cut corners and end up causing more problems than they're solving. So thinking about equipment access, again, we're talking semis here. You need roughly a 55-foot turning radius for semis. You can maybe squeeze it down a little bit more, but any more than that, and all of a sudden you're making multi-point turns to get that equipment turned around. You need wide access roads for these. 18 feet plus is kind of where you want to target for those semis. So again, if you're looking at grain storage here, thinking about where you're going to locate that, proximity to your feed center. If you're mixing some dry grain in the dairy rations, is that conveniently located to where your other feed stuffs are? Think about, how far you're going to have to haul things, from your fields. Again, drainage, precipitation management, rain, snow, moisture, all of that needs to be considered. Make sure you get vehicles in and out. And these grain centers, they do create a lot of dust, a lot of noise. So you want to think about that. Maybe you don't want it right next to the house. Think about, is there going to be an effect on neighbors if you're close to other people? And then safety is the other one. I mentioned that with bunker silos, definitely with grain facilities as well. We need to think about, the safety of people working around those facilities. So I'm going to shift gears a little bit here again and try to make this a little bit interactive. I know you're just watching online, but you can play along at home there. So we're going to play the What's Wrong game. So I'm going to walk through a few scenarios here and just think about, as you're seeing these, what problems do you see in these examples, and could they have been avoided, or what would you have done differently if you were in this situation, you were going to build this facility? So we're going to start out here with a bunker silo. So just take a look at that and see if you see any issues there. So a couple that kind of jump out to me. One, it's kind of a tight area there. So they've got bunkers oriented a couple of different directions, and it looks like there might be some access issues there to get feed in and out and to fill those bunkers. So that's something to think about. Another one that I kind of run across here in Northeast Iowa a fair amount is, we have very hilly topography, lots of little creeks and streams. So you want to think about how far away you are. If you have some leachate coming out of that bunker, is that going to cause a water quality problem? So that's something to think about. Where are you going to contain that leachate if you do have a problem? And in this situation, you would never know this unless you're, familiar with the facility, but the property line is actually there where that yellow line is. So this producer doesn't even own that pasture next door there. So if there was an issue and they needed to contain leachate, where is that going to happen? There's really nowhere to do it in this situation. So again, just think about these things, as operations expand and you add more bunkers, do you have room to do it, or are you better off moving those somewhere else? Okay, here's another one. This is the hay shed. So we're just going to take a look at this. So the white building you see on the right, just looking at the sat photo here, it looks pretty good. You don't really see many issues from the air, but you get down to ground level here, you start seeing some potential concerns here. So a couple that I see here, well, one, there's really very poor access to the backside of the shed. So there's a utility pole on the way there. That road going around to the backside of the shed is too narrow. There's no way you're going to get a semi back there. It's difficult to even get a bale trailer back there. So think about this. If you build a shed, are you going to be able to access? Ideally, you want to have access doors on both ends. Another issue here, the driveway is too steep in this case. So this facility was also being used for commodity storage, cottonseed, mineral, things like that. And so there's issues here trying to get those walking floor semis backed up into this facility to get them to unload. And they do not like to unload when they're on a downhill slope. So you think about that as well. If you're doing commodity sheds, you don't want basically a too steep of an incline outside that shed. You want to be relatively flat backing in with those walking floor trailers. The access door here is probably too small. It could have been taller for sure. It could have been a little bit wider. Now, if we take a look at the back side of the shed, again, very difficult to access. there's not enough room to load and unload bales or anything else in the backside of the shed. There's pretty poor drainage. You can see the whole thing is built into a hillside here. And I caution against digging things into a hillside because you can run into these issues with drainage and with not having enough room to access that building. So same farm here, we're looking at the whole layout. So do you see any issues here potentially with how this farm's laid out? So I'll just kind of walk through a few here. So one, there's no real central feed storage here. So if we look at silage storage on this farm, there's 4 different tower silos there. They're not located next to each other, so there's issues with that. Now, if we look at high moisture grain, we've got a silo in a different location. If we look at dry grain, again, that's on the north end of the farm. If we look at hay storage, we've got 2 different locations where hay is being stored. The bottom left there is the old dairy barn, and then the hay shed on the right. If we look at bulk feeds and mineral mixes and things like that, there's 3 different locations on this farm where those are being stored as well. So just think about mixing feed on this operation. It's just a lot of extra time driving around to access these feed stuffs. So that's something to think about. This whole farm, fairly typical for Northeast Iowa. It's all built into a hillside, so there's runoff issues. It slopes from north to south as well as from east to west. Just generally poor accessibility. The driveway is not really wide enough to get large trucks around in this facility. And generally, I see this a lot. It's been expanded over decades. So, starting back in the 1950s on through, the mid 2010s. And so not really a good long-term plan here for how this facility was laid out. So I can pick on this particular example because this happens to be our family farm where I milk cows for a number of years. So I dealt with these things firsthand. And so I guess I'm just kind of cautioning people, think about, how is this facility going to be laid out in the long run? Do you have room to expand? And if you don't, you might want to think about just ripping the Band-Aid off, which is what we did, and just start over in a different location where you've got more room to grow and expand that operation. And, move those cows to a different location, start moving some of that feed storage to a different location. So what I want to do here is I'm actually going to switch screens here, and I'm going to show you this Google Earth Pro tool. So I use this a lot for laying out facilities. It's a very handy tool. So it's there's a lot of things you can do with it. There's a measuring tool in here, just some other things sort of unrelated to what we're talking about today, but you can pull in, soil maps, topography maps. There's historical imagery. There's a lot of kind of neat things you can do with this. And there's also, it gives you the elevation on the bottom right side there. So I'm going to try to switch over here to Google Earth. So is that showing up okay, Fred?
Perfect, sure is.
All right, so we're in the actual tool here. So this is a free download. Anybody can access this and use it. So we're going to use that same farm as an example here. You go up here, you just type in an address, hit search. It'll zoom you right to your location. So we've got the farm pulled up here, and you can kind of move this around and do like 3D overviews and things like that. I'm not going to get into that today. But just looking at our hay shed example here. So one of the things you can use this tool for, let's just say you're looking at some buildings, you're not sure, I can't remember how long that shed is. Well, just go up to your measuring tool here. We're going to measure a line. So you just click and drag, click on the other end. That hay shed's 104 feet long. Clear that out. Maybe you want to measure the width. So it's basically 40 feet wide. This is surprisingly accurate. You can get within a foot or two, even on buildings that are several hundred feet long. So that's one thing you can do with this tool. So another thing you can do is, let's say I want to think about, pretend that shed wasn't there and I'm going to build it the other direction. So would that work? Is there room to do that? So we can measure out another line here again. Our shed was 104 feet long. So I'm just going to click here somewhere and we're going to drag out a line. 104 feet. Click on that. I'm going to save it. Now you can You can name that, you can save it if you want. You don't certainly have to. I'm going to add another line. We're going to go 40 feet wide. We'll just click on that. Save that line. I do it this way because it's a little easier to just draw these with lines rather than using the polygon tool, which is what I'm going to show next. So now we're going to basically draw out our new hay shed. I'm just going to use those two corners as a reference to get it roughly squared up here. And then once you've clicked those, you can kind of drag them and get it squared up. Okay, now I'm going to save that. I can go in here. Maybe it's a little harder to see there. I want to make my line a little wider. I could do that. I can change the color of it. I can do it filled in, whatever you want to do there. There's lots of options. So there's my new hay shed. So now let's take a look at that. Is that a good location? Well, I mentioned one thing. It might be a little hard to see on your screen at home there, but the elevation is down here on the bottom right. So as you move your cursor across this screen, if you can see that, that number is climbing. So our elevation here, as we move to the north, is getting steeper. So without even being on a farm, you can pull this tool up, just take a look at it, and you can see what the elevation is like. Get a general sense for where that water is going to flow without even having to be out there and looking at it. So we've got our shed here. So let's think about access. Can we get a semi into the shed? Even if this one, the existing shed wasn't there. So another thing you can do here, go to our measuring tool again. I'm going to draw out a circle. So we're going to think about turning radius for a semi. So I'm going to click and just drag. And what was our turning radius? It was 55 feet. So just taking a look at that. Do you think you can get a semi turned around in front of this hay shed? Probably not. Again, you're looking at a multi-point turn there. So again, if that's your situation and you have to build the shed there, just think about that. How are you going to get that equipment turned around? How are you going to access it? So those are just some of the things that you can do with this Google Earth Pro tool. And you can save these images right now. It's just in this temporary places, but you can name that and save those, and you can come back and look at them later and change it and have that for future reference. So that's it for the Google Earth tool. I'm going to just stop sharing here and we'll go back to our PowerPoint. All right, is that showing up there, Fred?
Sure is. Yep.
All right, so I'll keep going here. I just want to talk about some design tips now. So I walked through facility siting and showed you the Google Earth Pro tool that you can use for that. So now just get into some general design. Not going to get super into detail here, but just for some different facilities. So we'll start with hay sheds here. The bays on those, if you're going to do bays, those are certainly optional, but somewhere in that 26 to 32 foot width tends to work out pretty good for the bays for these hay sheds. Again, think about how long is that shed access in and out. If you need to go in there with a loader tractor and you've got a really long building, is it wide enough to turn that tractor around? That can be pretty handy. So the example I showed from our farm, that hay sheds, it's awfully tight in there trying to turn a tractor around. It's doable, but ideally that shed would have been a little bit wider. Think about airflow for hay storage. Allow a little bit of airflow between those bales because they will sweat, when you put fresh hay in. We don't often think about ventilation. I talk about ventilation a lot for livestock facilities, but for hay sheds, it's pretty much overlooked. Now, if you've got a hoop building like they're showing here or something with a nice wide open front on it, or it's just a roof, that's not really an issue. But if you've got a fairly enclosed hay shed, especially if you're going to shut the doors, those bales will sweat. It might be a good idea to put in some ridge vents or just have some eave openings just for a little bit of airflow to get that moisture out. And again, there's no perfect way to store hay. There's all kinds of different options. I'm not really going to get into design on this, but just evaluate that cost per bale for these different layouts. Seeing more and more hoop buildings, they're a relatively inexpensive option right now, and they're very flexible. If you don't want to use it for hay, you can use it for machinery storage. You can put livestock in them. So that can be a good option to look into, but you do have to consider how often you're going to have to replace that roof when you look at the economics of that. Thinking about sidewall height for hay storage, I'd go at least 18 feet, more if you can afford it. One thing I see in a lot of facilities, on the right-hand photo here, these knee braces, when you're stacking round bales up high, it's hard to see. You're trying to stack 3 high or 4 high or whatever it is. These tend to get snapped off. And you do need those for structural integrity especially in these tall buildings, they need to be able to withstand the shear force from heavy winds. So try to make that sidewall high enough so that you're not breaking those things off when you're in there stacking bales. Here's another example on the left. I call it skid loader disease or loader tractor disease. You get these bales up in the air, and if your ceiling height isn't high enough, it can be pretty easy to snap off those rafters. So that's something you want to consider when you're designing. Looking at commodity sheds, sloping that outward a little bit so you get water draining out. You certainly don't want water pooling inside your bays. Same thing with the pad outside here, but again, you don't want to make it too steep because you can have issues there with, getting semis backed up in there to unload. Ideally, in a perfect world, you'd add a couple extra bays, more than you think you're going to need. Think about processing hay, processing grain, things like that. It's handy to have those extra bays where you can do that. And then these precast walls, it kind of depends on how you want to design it. So the picture on the left there, they're basically permanent. That can be an advantage because you can basically set the walls first and then pour the concrete floor. Saves you a little bit on concrete. It's a little bit easier. You're not bumping into those walls when you're scooping feet up. But if you're inside a building, it can actually work pretty well to just set them on top of the floor. So that gives you more flexibility because now you can move them around. If you want to make that bay a little bit wider or a little bit narrower, you want to put something else in there, you can just move it out of the way. So just think about that. There's no right or wrong answer. Either way can work. Structural issues. This is another thing that unfortunately does happen. Tend to not see it as much in hay sheds, but certainly in livestock buildings where we've got, more serious air quality challenges and ventilation challenges. Those truss plates, they can get rusty. So you want to keep an eye on that sort of thing, especially like that middle right picture there. If you start seeing those, pulling out of the wood, or you start seeing that wood to separate, that's a serious issue. And you need to get somebody in there to address that, fix that, get an engineer to take a look at it, because you get to that point, you're, certainly at risk of that building collapsing. And then fasteners as well. If that steel starts to rust and the fasteners pull through, you lose that structural strength. You see on the left side there, the top photo, that can happen in a heavy wind. You see that steel on the bottom edge. That tends to be where we see those fasteners give out, and it just starts peeling that back. And, you can even potentially have a complete building collapse, as you see in the bottom left there. So just inspect your buildings every so often. Keep an eye on them. Take a look at your truss plates. Take a look at your rafters. See if you've got wood rotting out or truss plates pulling out. Drainage, another big consideration. Make sure you've got that earthwork done so that water drains away from the site. The picture on the left there, that hay shed, they put a gutter on that. That can be okay, but tend not to see that on, larger buildings, especially if they got a steeper roof. In this part of the country, we get a lot of snow accumulating and ice, and it all slides down and rips your gutters off. So it can sometimes be better to just go with a French drain type design, pour some gravel and put a tile in it that's sized to handle that water and just get that away from the site once it hits the ground, rather than trying to use gutters. Then obviously for bunkers, you got to think about leachate containment. If you've got a lot of it to deal with, you might need some sort of a treatment area. So think about where you're going to locate that. Switching to grain storage here, just thinking about, planning grain facilities. Again, same deal. Think about the future, allow for expansion. It's ideal to have at least 2 bins for each type of grain. So say you're storing corn and soybeans, just gives you more flexibility. Maybe you're in an area where you've got wheat or whatever else. Having those different bins, for different grain types gives you more flexibility. Try to have that control center centrally located with the fuel storage near the dryer. Think about expansion. Ideally, you've got a central loadout facility. If you can, try to bury your power lines. This goes for any facility, not just grain facilities. It's just safer to get those underground. You don't have to worry about tall equipment catching power lines. You don't have to worry about power poles in your way. And then the traffic flow, again, is important for grain facilities. Sometimes there's, you know, nowhere to back up a semi, so you need one-way traffic flow there to get those trucks in and out of the facility. Looking at sizing, so again, I'm not going to get into the details on economics. There's some tools that you can use to try to help make some of these decisions, but just make sure it makes sense. Few, smaller bins, having more of them gives you more flexibility, but sometimes it's easier and cheaper to just have, one or two big bins. So just think about that trade-off there. And, maybe it's worth, putting in some extra storage and storing grain for somebody else just to try to help pay for those bins. So sketch it out. I encourage everyone to do this. This is just an example of a grain facility here. You do this for anything. Think about traffic flow. Think about where you're going to locate these bins or hay sheds or commodity sheds or whatever it is, and how that's going to work with the overall flow of your facility. I did this in the Google Earth Pro tool, so you can do things like that in there, and you can save those sketches, or you can just sketch it out on a piece of paper if you don't want to mess around with that. Just an example here, you can use some graph paper. You can't see the lines here, but this was just drawn out on graph paper. This was a facility where they had some damage during the derecho, and so they had an opportunity to kind of hit the reset button and think about, okay, how are we going to expand this in the future, and where would we put these bins? How would the traffic flow work? Things like that. So, just get out a pen and paper and start scratching things down and getting some measurements in that before you make any serious plans to start building anything. So that's really all I had. I'll wrap it up there, and happy to take any questions. I do have my contact information there as well. So yeah, if anybody's watching this online later, just feel free to reach out to me.
Brian, one question I would have is when you take a look at some of these larger dairy producers are starting to take a look at the corn silage in the bunkers and the bags for the alfalfa. Any thoughts on that? Because just some of the people they're coming back with the thought about they're really thinking they're reducing their costs quite a bit by putting their corn silage in a bunker, a nice covered bunker versus putting in the bags. And I know that data from Wisconsin, it's a little bit old, but I'm just kind of wondering if the relative sense of that might have changed a little bit.
Yeah, that's a good question. I think generally corn silage is certainly more suitable to a bunker. You can chop a lot faster, you can fill faster, you can, generally get it packed pretty well. So that's between the two, that's certainly a better option for your bunkers or your piles. With alfalfa or, with other forages, you're doing 3-4 cuttings a year, tend to have less volume. It works a little better to have the flexibility of bags, in that respect. As far as how the economics of all that shake out, yeah, you really just have to put a pencil to it for your operation and see which one makes the most sense.
Got it.
Brian, one of the things that I'm seeing as afterthoughts is that location where we load the mixer wagon. If they're well thought out and they've got a minimal amount of wind blowing all the expensive product down to the lane. Any thoughts on how you want to site, a place to load that mixer wagon?
Yeah, that's a great question. So again, it comes down to cost, but certainly if you're going to build a new commodity shed, I would think about that. We actually saw a nice example on a local farm here where they had room inside that shed, so they could back their mixer wagon in and load that stuff and get out of the wind. So that's especially if you're really expensive mineral mixes, they tend to want to blow when you're up there loading those outside, trying to get accurate weights in the wagon. So it's hard you'd have to look at the shrink, and kind of do the math on it, see if you can justify building, a little shelter or something, at least a windbreak near where you're loading those TMR mixers to help cut down on some of that wind loss.
Brian, any thoughts about just like the feed pad surfaces from your macadam base type ones to the blacktop to I've seen a couple that gets cemented out, and I know it's a pretty expensive thing to do that, but long term, I'm sure the cement's probably better. But what do you think about just the typical cost of just the macadam base versus the blacktop?
Yeah, that's a great question. So I guess my personal preference on a bunker or a pile would probably be the blacktop. Concrete tends to not hold up as well to those silage acids. So if you can do a nice job pouring a blacktop, that's kind of ideal in my book. But you can certainly get by, if you're going to do a pile and you don't want to put walls up right away, you can certainly get by with the macadam base. Put down at least 6 inches of large diameter rock, 2 to 3 inches, and then cover that with some lime screenings and make sure it's really well packed. The challenge is there, drainage. Obviously, you're never going to get it perfectly level. And I see a lot of places, you go to start loading feed and you start digging a little bit and making divots in your surface and you start pooling water. So economically, it's certainly a heck of a lot cheaper. And I think I would prefer, that gravel and limestone base over mud any day. So I think that's kind of a no-brainer to at least pour the gravel base with the limestone, because you're going to have to do that anyway, whether you're going to do concrete or blacktop. You still have to have a decent base under it. So I would go ahead and pour the gravel and start there. And then once you have the extra money, then you can start pouring asphalt.
Okay, thanks.
We have a lot of our piles on pads that are getting some age on them. So as producers are retrofitting those, have you got some thoughts on what you think is the best product to resurface those, make them solid, and get rid of the chunks that are coming out?
Yeah, that's a good question. That's not something I have a lot of experience with, honestly, as far as, one product being better than the other. So I would just encourage them to talk to other farmers who have done it and see what product they use, talk to the local contractors and see what they're recommended for, that resurfacing.
Some of these plasticide cements really look neat. They're fast. They seem to be durable. They withstand acids, but I'm just, what's the life going to be? Are we going to do that every 10 years instead of 20?
Yep. Yeah, that's a good question. I don't really have a good sense on the lifespan on some of those products. So yeah, try to find somebody who did it 10 years ago and see if it's see if it's still there or not.
Well, Brian, it looks like our questions have kind of dried up. We want to thank you for putting this information out there. A great program that even guys like me will be able to take something home and understand what was presented. We're going to mention, if you're viewing this in the archives, it'll be available. Give us 4 or 5 days when you view it. You'll be able to then also take the evaluation. We encourage people to do that evaluation so we in fact can see what we need to change. Remind everybody that our next program will be March 1st. It'll be rations for 70%, forage, and 100 pounds of milk per day. Presenter will be Dr. Gail Carpenter. At this point, thank you for attending. We appreciate the time you spent with us.